All right, what's up, folks? These winter afternoons quickly turn into night. If you're working outside this time of year, you already know that. But what we got here, what we're talking about today, is the plumbing and electrical rough ends. We just passed our inspections. We inspected the other day, but had a few small things that were outlying that I'll talk about. Did have the re-inspection to cover the rest of those. We've got everything completely buttoned up, and we're ready for our spray foam installation. I'm just gonna walk around. I'm not really gonna show you how to do plumbing. I'm not gonna show you how to do electrical. I did sub out the electrical on these. It's just not something I wanted to dive into. I really just don't have the bandwidth to learn something like that to get it right. But to make sure we got it right, I did sub out that electrical. I did all the plumbing myself. I'm gonna take y'all on a quick walk around, show you where the water goes in, where the power goes in, the venting, and stuff like that, and then we'll hop inside and just take a look at everything. I'll talk about the finer points of what it takes to pass an inspection, but everything you're going to see is sufficient to pass inspection for the NOAA certification. Real quick update, just on the outside, you can see, I don't know how much of it you can see, we've got all of our doors and windows in except for one door, and we kind of chose the budget French doors and absolutely paid for it. It was not a great experience trying to get them installed. We got one to work and the other one is a lost cause. We've ordered a sliding door for that one. It's going to be a little bit easier of an install, and we've already got our custom size rough ends, so just had to get something a little bit smaller, and we'll build the wall out to match the new width of the sliding door. I didn't get any videos done on the doors. I'll try to get one done on that sliding door, but they go in essentially the same as windows. There's just a little bit more complexity with lining everything up. Your window is a rigid, solid thing. You want to make sure it's level, plumb, whatever. But with the doors, a single door is not too bad, but with a French door, there's a lot of stuff that you have to get just right. So expect trouble. I did see somebody talking about French doors, and they basically said if you're not going to pay $2,500 for French doors or more, go a different route. That proved to be pretty true. Wish I would have seen that video before I did this, because we did burn about $2,000 on a door. I think we put about $1,800 into each French door, wound up scrapping one of them, had to replace that with a $2,000 sliding door. That is definitely one thing it is worth paying extra for. If you're going to do French doors, get some good quality doors. Don't just go with the builder grade spec, here's my dimensions, just give me a door. That may very well bite you. It worked one time and it didn't work the other time. That's what they look like. These things are really coming along. Once we get that sliding door in there, they'll both be ready for siding. The one that does have the French door in is ready for siding. Without further ado, we're just going to take a few steps around this thing, look at the stuff on the outside, and then we will hop inside and go through the nitty-gritty. All right, first thing we'll look at is where the water is coming in. Basically what you have here, what we decided to do is a hose pipe connector. I've got 3/4 inch PEX coming in. You can do 1/2 inch the whole way. I honestly don't know why I did that, but it made sense at the time, so I did it. Obviously this is just kind of sitting here. Once we get our siding on, we are going to kind of frame this up and get that hard fixed to the trailer. And in no particular order, our vent line on our drain system is exterior here. I would have loved to run that through a wall and maybe up through the roof or just out higher without having this whole vertical member, but we'll paint it to match the siding, and it's just really not that big of a deal to me. It's on the back side of the house, so it's not really on the show side, and it's not a huge problem. It would have been a huge problem to try to route that inside. Ultimately, that's the decision we made because we don't have very many interior walls. This here is from our bathroom vent. You do have to have a bathroom vent that does exhaust either to the outside or to your existing vent system, and that does have to be on a humidistat. That's part of the NOAA requirement. I'm gonna flip y'all around and we'll look at the drains underneath. Under here, we've got, that is from our shower and cuts over here to the main line. I ran everything down one line, so everything is in line. This is gonna be where my toilet comes in. Real quick point of clarity here. That dripping you see on the end of the line is a temporary clean out cap that is just not sealed well, but I put it on there for sake of the test so I could release all that water. Now that little drip on this side of the toilet tee is actually a leak. That fitting did not get any PVC cement. So I was able to, because it was on this side of that tee, I could pull the pipe forward and separate those and get some glue in there, which I did, and it's good and sealed now. So there you go. Did find out on the inspection that this needs to be a sweeping tee, not just a standard tee. It's got a little bit of a sweep to it, but they really want to see a larger sweeping tee there. It's not enough of a deal breaker to have to go in. They were okay with it. They just said, get it right next time, basically. We got 3-inch line here, and here's where we come down to 2-inch line, and this is our vanity in the bathroom. And then if you keep going down, you'll see the stub up on the kitchen sink. This thing needs to be on at least a 1/4 inch per foot drop. We've got more than that. Basically, they're not going to measure that. They just want to see a visible slope. But the actual requirement is a 1/4 inch per foot drop. So if you've got 4 feet of line, you need to come down 1 inch or more. And then 8 feet, you would need to be down 2 inches. Nothing too crazy going on here. We've got some pipe straps just bolted into the trailer to support this thing down the line. And got some, I think you can fiddle focus, see that shower drain P-trap there. That's what you got underneath. And then coming further down the trailer, we've got our electrical panel sitting right about here somewhere inside. And then we just ran the main power line from the panel down through our base plate, through the trailer there. We've got a sleeve of conduit through all those to protect that cable. And then once we get them on site, we're going to hardwire these, so we'll run underground conduit all the way to this location and run conduit up and tie it in completely. That way it's good and protected. I think on most of these things, what people do is like your RV connector. So you would have your main power come to an RV connector that's just like stuck in the wall there. That way you can plug in your power whip and go that way. Since these things are going to be very permanent, we're not planning on moving them once we get them up there. We're going to go ahead and hardline that way. That way we can keep everything protected. We will walk inside here and show y'all what we got going on. All right, so it is a new day. I got a little caught up yesterday and it got dark on me. But now we're inside. We'll do a quick walkthrough overview of everything, and then I'll kind of talk about some of the finer points. This is our main electrical panel. You do have some clearances that you need to make sure to maintain this way and out towards the camera. It was no issue in this position, but some places get a little tight, and the code requirement does require you, I think, to have 24 inches of working space here and like 3 feet or something like that. Don't quote me on that, but just be aware. Main power comes in through the bottom there. We've got a sleeve of conduit just protecting that cable. And then from the panel, we come up and over our door. We've got all of our stud guards on there. What those are gonna do is prevent any nails or screws or anything from your drywall, or down the road if you're hanging something on the wall or anything like that. That's gonna keep that protected, because once you get your spray foam in, you don't wanna mess anything up. It creates a lot more trouble to go back and fix. We got that. One of our issues with the first inspection was these red staples. Initially, we just had zip tied bundles going up through here and had the zip ties stapled. That was not good enough. They did want those separated out. I think it's 6 one, half dozen the other, but that's just something that they wanted to see. Here we're gonna have our kitchen run. We'll have a section of countertop here, and then it's gonna go into your sink. You've got your 2 outlets for the countertop up there. That is required. All of our wiring run under here with stud guards. Here we're gonna have a little oven insert in the cabinet, and then the top outlet is gonna be for a double-eyed stovetop to mount into the countertop. And then that's gonna be our fridge. Whoop. My gimbal's acting crazy on me. That's gonna be our fridge. We'll get into the bathroom here. We're gonna have the vanity here, then the toilet, and the shower goes here. You can see we've got all of our plumbing run. It's just all PEX line, and then our drains are PVC. To keep those drains in a straight line, I separated them from the wall, all the same distance. That way I didn't have to have any turns in my main drain line. So all 3 of these are on the same line. and then our shower drain comes over. So I tried to position you here where you can see all three of these. When you're locating these drains, you want to be absolutely sure that you're in the right spot. Toilet drain is going to be 12.5 inches on center from your stud. If you've got a finish wall, if you've got drywall on there, you need to be 12 inches off of that drywall. There's a lot of clearances to watch out for between this stuff. You've got to have 15 inches from the center of your toilet to your shower and the vanity beside it. That one's not quite as important because you've got lots of different toilets you can work with. But locating the shower drain was kind of the most tricky part for us on this. Initially, we picked out a shower. We pulled the drain location from the paperwork on the shower, went ahead and drilled it, set it, good to go, only to find out that that shower was back ordered. We didn't have it in hand yet, but we were just counting on that lining up. And the shower was back ordered, so we could not get that in. And then could not find a shower pan that had the same dimension from this wall. So what we ultimately had to do was get an offset drain that offsets the center of your drain and your actual drain pipe a little bit. And then we had to cut into the metal joist member just a tad. We had to notch out the corner of it to be able to get that offset drain to fit in there. That was sort of poor planning on my part. We do have a metal floor joist running exactly where most of your standard drains fall. So instead of trying to do a custom pan or anything like that, we got as close as we could to that joist, and that gave us enough offset, but we couldn't set the drain down far enough because the slanted part of the offset was interfering with that corner. So we notched that corner out with a hole saw, made a jig so we could come in on an angle and cut that with the hole saw, filled it up with foam inside the joist there just to keep that from being just kind of exposed to the elements. So we did get that in, it works well, everything fits well, but these drains are something you really want to make sure you get right, because once you put them in, they're pretty tough to move. I'm going to move around. We'll be on the other side of this wall basically. This is going to be our outdoor storage, and I will show you the plumbing manifold where everything comes in and what we did and why we did it. So this is our main intake plumbing manifold. This is the main line coming from that hose that I showed y'all on the outside. We've got a cutoff valve here, and we put in a pressure regulator, which is a great idea. You don't always know how much pressure you're going to have at your supply. So if it is too much, it can be dangerous to damage these fittings, and it can also ruin your appliances. It can mess with the internal components of your appliances if your water pressure is too high. So what we did, we come out of this regulator and then down through here, through this pressure gauge. You will have to pressure test your plumbing. They require that you maintain 80 psi for the 10-minute test. That's what's required. If you can't get full 80 psi from your supply, I've got really good water pressure here, so hooking the hose up got us well over 80. But if you can't get that kind of pressure, talk to your inspector. A lot of times they're going to be okay with 70. I don't know how low they're willing to go. But as long as it does hold a constant pressure for 10 minutes and it is a good acceptable pressure, they'll likely let you go on that without going all the way to 80. So definitely put a regulator in your system. They're like 60 or 70 bucks a piece. They're not very expensive, and that's going to help you down the road anytime you need to change your pressure, so you can save all your plumbing and you won't have to go through here and repair anything. And anytime you got a regulator, you need a gauge. You need a gauge for your test. You could hook it up to one of your outlets somewhere, do the test, and then unhook it and plug the hole. But we decided just to keep it in the system because we do have the regulator. So that's a good idea. So then it'll run up here, and then we split off. This is a little janky. This is where this will come out of our hot water heater. I'm trying real hard to stop saying hot water heater because it's a little bit redundant. But this will run into the water heater and this will run out of the water heater. The reason we've got these bridged over is for that pressure test. You've got to pressure test your entire system, so those lines did need to be connected to get that done. These two legs here, we decided to leave in case we need to add any additional filtering to the house. We're going to have filtering for our well pump at our well house, but if we do need additional filtering or just decide we want it, this is going to create a really easy way to tie in a filter into the system, then we'll just cut this valve off and it's going to run through the filter and back into your system. So not too complicated. Definitely take the steps to add the regulator and the gauge in. It's going to save you some time and effort down the road for sure. Like I said, I'm not going to talk to you too much about how to do the plumbing. The PEX systems are great. I use these little crimp clamps because that's the thing I have the tool for. I used them a long time ago and never really swapped because I have the special tool for it. There are several other different kinds of crimps and clamps and stuff you can use on this PEX system that are all accepted and are all going to perform well and hold under normal circumstances. The PEX is a really easy system, highly recommended. I don't think anybody's running supply lines with PVC anymore, but if you are, definitely give PEX a chance. It's much quicker, much easier, and you get a lot more leeway in it. You know, it's a lot more flexible. You can get away with more. I think that's all we got on the plumbing. I'm going to step back in. We'll talk a little bit about the electrical, but I don't have a whole lot to say about that because I did outsource that to another guy. So we'll go through some of that, some of the finer points for the inspections and things like that. Like I said, I can't give you too much expertise on the electrical or how to run electrical. It's something I didn't have the bandwidth to learn how to do. I didn't really have the desire to learn how to do it. And found a great guy. Shout out to Casey Jones here in Winchester, Tennessee. I think it's Jonesy Electric. So shout out to him. He did a great job with these things. It saved me a ton of trouble. Very happy with it. But I kind of gave you the general overall walkthrough. Like I said, these staples are something that they were looking for on the inspection. You do need to have everything in. Basically, when they buy off on this inspection, you're ready for spray foam. They're actually in the other unit spray foaming right now, so I'm trying to get this video done. But you've got to have any of your HVAC ducting you've got going on, any of your wiring, any of your plumbing. It all needs to be totally buttoned up for this stage 3 rough-in inspection. Because once they buy that off, you're good to spray foam, and then you're kind of pregnant. It's hard to go back from there. So you do want to make sure you've got good cable organization. You want to make sure you've got your stud guards. That's something they look out for. Anytime you penetrate through your top plate or bottom plate, you've got to have that fireproof foam. That is just a requirement, top and bottom. So any penetrations through there, you want that orange. Great Stuff makes it fireproof foam. Works just like spray foam. I guess it's just fireproof. But that is something they require. There's a bunch of stuff that I won't get into as far as which, your bathroom circuit's got to be 20 amps. You've got to have a dedicated outlet, all your GFCIs, all that fun stuff does definitely apply, but I'm not going to give you too much information on that. I guess that's really about it. Kind of higher level, we're running 200 amps to each house because we're going to have a hot tub. Really 100 amps would be plenty for this house, plenty of power, but we are going to put a hot tub. They typically run on a 50 amp breaker, so that would be dedicating half of our power to the hot tub and only leaving 50 for the house. We didn't want to do that. So we've got 400 amps coming off of the pole to a meter, and then off that meter we're splitting off to two 200 amp locations for each house. You got to have a hardwired smoke detector. That is code requirement. I don't remember if I talked about the bathroom fan. I know I did yesterday, but that video got kaput. You do have to have your bathroom fan on a humidistat and routed to either outside of the building or to your existing vent system that eventually routes outside of the building. That humidistat has to be on 24/7. What that is anytime your humidity gets high inside the building, it's going to kick on that humidistat, it's going to run that fan, pull that moist air out of there. And then once the humidity level is to a certain point, which is all adjustable on your switches, it's going to cut back off. Generally, that means anytime you turn the shower on, the fan's going to come on. If you did develop more humidity for any other reason throughout the day, it's going to pull that air out and keep it nice and dry in here to keep your mold down, keep your moisture down. Always a good idea, but that is a requirement. You can get a bathroom fan that does have a humidistat on it. We're just using a standard fan with no humidistat, and then the switch for the fan on the wall, we will put in a humidistat switch. That's definitely something that's required. Mini splits do not exchange air, so they're just cycling the air that's in here. So that's not a good air exchange. It doesn't count for that requirement. And most of the time people are doing mini splits in these. This is what we're doing. I'll show you the mini split. I don't think I did that. That's really all I got for you on electrical. If you're an electrical person, you know all this stuff. And if you're not, you're probably subbing it out. So kind of lean on the experts for that. I'm not going to pretend to be one. I'll pretend to be one on some of this other stuff, but certainly not on electrical. That's not a beast I want to wrestle with. I'll show you that mini split and we will wrap things up. All right, so this is our back wall of the tiny home. This is going to be kind of your living room area. We'll have the sleeper sofa here, probably put a TV on the wall and angle it towards the sofa. Our mini split is going to go directly above this window. They do require, I think it's like 90 inches is minimum height. So you do want it good and high up there for it to work effectively. We decided instead of routing all our cables straight through the wall, like a lot of people do with mini splits that are going on existing structures, to route our cables through or not cables, but route our lines through the wall. That way it's going to keep those good and hidden. Otherwise, these are running on the outside of the wall, on the outside of the building. They do make garden kits that you can cover them up, trim them up with, but they are kind of bulky and just ugly. So if you have the opportunity to hide it, it's definitely a good idea. It's going to make everything have a nice clean look. If you've ever seen these mini splits that have been installed to an already complete building and you just kind of have that wad of lines coming down your wall, it's not a great look. So that's what we decided to do on those. I think that about covers everything. If you've got any questions for us, definitely reach out. As far as the inspections and stuff go with the electrical, I'm happy to discuss some of that stuff. Your more expert electrical questions, like cable calculations, how thick you need for different circuits and stuff like that, leave that to the experts. I'm not gonna try to tell you how to do that. But yeah, I'm pretty excited. We've got spray foam coming in today. They're in the unit right beside us working on that, and then they'll get to this one right after that. So after the spray foam, we're ready for sheetrock in here, and after that, you're kind of blowing and going. You're ready for trim, floors, paint, cabinets, all that good stuff. It's going to start happening very quickly. Really excited with the progress we've made. We're a couple months behind schedule, but that's really not a huge deal considering we were just taking a random guess at everything. So I'm pretty happy with that. Sorry this one's pretty unorganized. I've been for the last couple days trying to make sure that X gets done so that Y can then get done, and Y can get done so that Z can get done. This morning I was putting up my final bits of interior sheathing for the spray foam guys and putting up my dead wood for the drywall so that I don't have to dig out any spray foam and do that. But that's been very much the nature of the last few weeks. Is the spray foam guys come in this morning and I'm like, all right, hold on, I got a few more things to button up. And I've already got a couple other things I've got to jump onto after wrapping up this video. Y'all have a great day, have a great weekend, week, whatever it is when you're watching this. Definitely reach out if you have any questions or comments, and just thanks for tuning in. Appreciate it, guys. The next video, I'll come through and do an overview of the spray foam, kind of like I did this one, and then we'll keep on rocking.